Today we are going to discuss section 2.2, analyze conditional statements. So our goal is to write definitions as conditional statements. So first, what is a conditional statement? It is a logical statement. It is written in what we call if-then form. How this goes is if hypothesis, then conclusion. You'll also see the hypothesis here. That will also be called P. So you'll see this called if P, and your conclusion, sometimes called Q. So it would be if P, then Q. If hypothesis, then conclusion. When rewriting a statement as a conditional, or as a conditional statement, or if-then form, there may be times we need to add words. Specifically, we cannot have pronouns in the hypothesis. So our first example here, all whales are mammals. If we think about it, a whale is an animal. So we will say, if an animal is a whale, then what do we know about it? Then it is a mammal. Sometimes you will have a statement where the if is already in it. For example, 3 points are for here if there is a line containing them. So we know that if there's a line containing that is going to be our hypothesis, unless 3 points are collinear. Now, we aren't going to directly take this as we see it. So we will have if there's a line containing, we can't use the pronoun them, so what is them described? The 3 points. So it'll be if there is a line containing 3 points, then 3 points are collinear. Right, so if there is a line containing 3 points, again, we cannot use the pronoun them. We have to refer to what is them referring to. In this case, it's the 3 points. So if there is a line containing 3 points, then what do we know about them? The points are collinear. That would be our condition statement. A negation is the opposite of an original statement. So, for example, the car is blue. The opposite, the car is not blue. So, to write a negation, we use the word not. So, in this case, the car is not blue. So, the opposite of being blue is not being blue. Alright, we've already talked about the conditional statement. Is written if P, then Q. We are going to use this for our definition of each type of statement. The first one is the convert statement, in which we will switch the hypothesis and conclusion. So we switch P and Q. The converse. The inverse is the negation of the condition. then not Q. So we add the word not. So if not P, then not Q. That is the inverse statement. The contrapositive then is the negation of the converse. So that would be if not Q, then not Q. I'd like you to take a moment and try to write the statement. If you are a soccer player, then you are an athlete, and write the converse, inverse, and contrapositive of them. So take a few minutes and see if you can do that. Again, the converse statement is if Q, then P. So this would be, when we look at our original statement, soccer player is our P statement, athlete is Q. So this would be, if you are an athlete, then you are a soccer player. Again, we're not talking about the validity of these, we are talking about just writing these as statements. So then inverse is if not P, then not Q. So if you are not a soccer player, then you are not an athlete. And lastly, the contrapositive, if not Q, then not P. If you are not an athlete, then you are not a soccer player. Equivalent statements are two statements are both true or both false. And what happens is they work in pairs. So the conditional and the contrapositive. So the contrapositive and the conditional are a pair, as well as the converse and the inverse. So we look at, now we're talking validity of statements. If you are a soccer player, are you an athlete? Are soccer players athletes? Yes, that's true. We look down here. If you are not an athlete, then you are not a soccer player. If you're not an athlete, can you be a soccer player? This is also true. So these are both true, which means they are equivalent statements. We look at the converse and inverse. If you are an athlete, then you are a soccer player. Are all athletes soccer players? No. If you're not a soccer player, then you're not an athlete. Just because you're not a soccer player doesn't mean you're not an athlete, so it's just a false statement. These, although they are both false, are still considered equivalent statements because the converse and inverse are the same. Perpendicular. This is a huge definition to understand. So the notation for perpendicular, it looks like an upside down capital P. Some people will write it with a box like that. But when you look in the text, it'll just be that upside down capital T. The definition is two lines intersect to form a right angle. That is the definition of perpendicular, to form a right angle. What it means is, so we have line L and line M. We would say that L is perpendicular to M, and we know they're perpendicular if the box is drawn. You need the box to show that it's a right angle. Remember, we cannot assume the right angle, so you cannot say it's perpendicular unless the box is drawn. You need the box to be drawn. A biconditional statement. This uses the term if and only if. You will see IFF is the abbreviation for if and only if. You won't see it too much in this textbook, but in future textbooks, if you're talking about logic and more specifically biconditional statements, you will see them as if and only if, abbreviated as IFF. It's when the conditional and converse, so if P then Q and if Q then P. So it doesn't matter which one you have first. If they're true either way, then it's a biconditional statement. And when doing these, start with writing the conditional statement, an if-then statement. Try doing that first, or at least identifying the hypothesis and conclusion, and that'll help you write an if and only if statement. So look at this one. Co-planar points are points that lie in the same plane. We're talking about coplanar points. That is our hypothesis. And that they lie in the same plane is your conclusion. Again, we call them P and Q. So instead of being if P then Q, it's going to be P if and only if Q. So we will say points are coplanar if and only if, you know, I have to write out if and only if, either way. So if and only if they lie in the same plane. And that would be your biconditional statement. Points are coplanar if and only if they lie in the same